In this bonus objective, we're going to look at creating an exponential function from knowing some points on our graph. All right, so the first thing to remember is that an exponential function is of the form y equals a times b dx. So if we can figure out what a is and what b is, then we're done. We know the form for our exponential function. All right, so what about this equation? All right, we know we have this exponential graph. All right, and all we know right now is that it goes to the point 0, 2, and 354. And we want to create an equation that looks like this. Well, a is our initial value. Initial is where you start out, which is actually what they're telling me right here. All right, 0, 2 is the initial value. So right away, I know that a is 2. Now I got to figure out what b is. And this next point is going to help me. It doesn't instantly tell me what b is, but it's going to help me figure out what b is. Because I can take this point, I can plug in 3 for x and 54 for y. And this equation has to be true. All right, so whatever b ends up being has to make this equation true. So now I can solve this equation and figure out what b is. All right, when we solve equations like this, we're trying to solve for b, which right now has an exponent. So the first thing we want to do is get that by itself. So what I'm going to do is divide both sides by 2. 54 divided by 2 is 27. And we have b cubed equals 27. All right, there's a couple different ways you can go from here, but one thing we learned in this unit is fractional exponents. So what I can do, if I want to get rid of the third power, I can multiply it by the 1/3 power. I guess 3 times 1/3 will cancel out, just like we do it all the times with fractions. But if I do that on the right-hand side, I also have to do that on the left-hand side. So again, the reason we're doing this is because those are going to cancel out, and that'll just give me b. Now b is equal to 27 to the 1/3. All right, but that's not a great answer because we have this fractional exponent. All right, but we also know that this 1/3 power is the same as the cube root of 27. All right, that's something we learned early on in the unit. And the cube root of 27 is 3. All right, because 3 times itself 3 times is 27. So my final answer is y equals 2 times 3 to the x. All right, that is the equation for this exponential. All right, so here's one for you to try on your own. Similar thing, you have the point 0, 5 and 2, 20. And here's the answer that you get. So the first thing you notice is that your initial value, because when you're plugging in 0, is 5. That means your a value is 5. Then I can use my other point, plugging in 2 for x and 20 for y, to get this equation here. Divide both sides by 5 because I want to get that exponent part by itself. And here's those two options. We had these types of problems in an earlier unit. You can just take the square root of both sides and get your b value. You tend to get plus or minus when you do the square root, but our base is always positive, so it's just positive 2. The other way, squares are kind of a special when we had that square root. But the other way you could do it is using our fractional exponent. So you use 1/2 to cancel out the 2. And then 4 to the 1/2 is the same as the square root of 4, which is 2. All right, so either way, you get b equals 2, and our final answer is 5 times 2 to the x. All right, so this is kind of the first way when they give you the initial value, and then solving your equation using our fractional exponents. However, knowing the initial value is actually very useful information that you won't always have. So how do we find it if we don't know the initial value? All right, so we look at this equation. They give us 1, 6 and 3, 24. Neither one of those has a 0 in the first coordinate, so neither one tells me the initial value. What I do know is that my answer is going to look like this. And each of these points is x comma y. Right, so I plug in 1 for x, I get 6 for y. So that's going to be this equation. And if I plug in 3 for x, I get 24 for y. So that's this equation. I had these two different equations and these two different unknowns. So this is something that we did really early on in the year. This is actually a system. And one way we solve systems is using substitution. All right, so what we can do is take one of the equations and solve it and plug that into the other equation. All right, so what we're going to do is, step 1, solve an equation for a. All right, so I'm going to always pick the one that has the smaller number. So I'm going to do this left-hand equation with 1 and 6. If we want to solve it for a, all I need to do is get rid of this b by dividing both sides by b. So 6 over b equals a. Our second step, now that we have a solved, is we can do our substitution. So we can take this thing and plug it into our other equation for a. So now we get 24. Instead of a, I'm going to write 6 over b times b cubed. Step 3 is to simplify a bit. You're always going to have this kind of fraction, but remember we have these exponent rules. If this b cubed is on the top and this b is on the bottom, we subtract the exponents, and that's going to give us b squared. And step 4 is to solve. All right, so how do we solve this? Just like we did the previous examples, we're going to divide both sides by 6. 4 equals b squared. And we literally just solved the equation. 4 equals b squared, b equals 2. Right. And then make sure we also don't forget to also find a. Right, but now we know that b is 2. A is 6 over b, which is 3. So my final answer is going to be y equals a, which is 3, times b to the x. All right, so that is our equation that goes through those 2 points. All right, one good idea that we're not going to do in the video just for time is taking your numbers and plugging it in. So if I plug in 1, I should get 6. If I plug in 3, I should get 24. Let's just do a couple more examples. All right, so this one, if we plug in -2 for x, we get 16. This one, if we plug in 2 for x, we get 1. And again, our first step is to solve one of these equations for a. It's really up to you which one you want to solve. Last time we did the left hand, so let's do the left hand one again. So if I want to solve a over here, I have to divide both sides by b to the -2. That's going to be a equals 16 over b to the -2. And I plug that into my other equation. So 1 equals 16 over b to the -2 times b to the first. All right, now we have to simplify this expression before we try to do anything else. Mainly when we're simplifying, I'm talking about simplifying the fact that we have these multiple b's. All right, but if we have b over b to the -2, negative exponents want things to go to the other side of the equal sign, so that b on the top is going to stay, but that b to the -2 is going to move to the top and be b squared. And if we have b times b squared, we get b cubed. Except for I just realized I made a mistake, so what we're going to do is change a couple things. All right, this 1 should be a 2, which means that one should be a 2, which means that one should be a 2, and it's going to actually give me b to the 4th. Right, so one mistake, because the x value should be 2. Now I have 1 equals 16 times b to the 4th. I can divide both sides by 16. Now I have the exponent by itself, so now I can get rid of it by raising both sides to the 1/4 power, because that's the opposite of the 4th power. And that's going to give me b equals 1 over 16 to the 1/4, which is the same thing as the 4th root of 1 over 16. And what times itself 4 times is going to be 1 over 16. Well, on the top, 1 times 1 times 1 times 1 is 1. On the bottom, 2 times 2 times 2 times 2 is 16, so it's going to be 1/2. So that is my b value. I can take that now and plug it back in over here to figure out my a value. A negative exponent can move things to the other side of the equal sign, or it can flip a exponent. Either way, there's a bunch of different ways you can solve this. I get 4 for a. So my answer is 4 times 1/2 to the x. All right, one more example before you try one on your own. Again, if you feel like you kind of understand it, try this one on your own as extra practice. All right, but I'll go through this whole one. All right, we have y equals a times b to the x. I'm plugging in 7 for y and -1 for b. I'm also putting in 80 for y and 8 for b. I'm going to solve. Again, you can solve either one. I've just been consistently solving the left-hand one, so I'm going to solve the left-hand one again. I'm going to divide both sides by b to the -1. I get a is 7 over b to the -1. which you could simplify here or later. So let's just simplify here for the sample. This is going to be the same as 7b. All right, so now what I can do is I can take this a and plug it in over here. So we get 80 equals 7b times b to the 8th. 80 is going to be 7b to the 9th. Divide both sides by 7. 80 over 7 equals b to the 9th. And here's where something happens sometimes with these. 80 over 7 is not a nice number. So sometimes for these ones, you're going to get just a not a nice number. So how do I get to my final answer? Well, I know now what I want to do is get rid of this 9th exponent by taking the 1/9 power of both sides. I'm going to get b equals 80 over 7 to the 1/9. And you can try as hard as you want to try to find a number you multiply by itself 9 times to get 80 over 7, and you're not going to get a nice number. So what you do is you would just type this in a calculator. You type in 80 over 7, raise it to the 1/9 power, and you're going to get 1.31. And there's not really anything you can do about that. So if you can't figure out what numbers are going to work, just use a calculator and figure out that this decimal is 1.31. And then we know that a is just 7 times that number, so a is going to be 7 times 1.31, which is 9.18. And so my final answer is y equals 9.18 times 1.31 to the x. And so here's one for you to try on your own. The numbers for this one should work out nicer than the previous one. And the final answer you're going to get is y equals 5 times 2 to the x. All right, so we make our two equations using our points. We solve for a, and we plug that into the other equation. We simplify a bit and use our fractional exponents to solve, and we get b equals 2. We'll plug that back in over here to figure out a is 5. All right, so time to practice now. This is going to be a Delta Math 1. All right, so there's an assignment on Delta Math. Complete those problems and you'll be done with this skill check.